the last part of this, go ahead and open up your books. Let me see, what page is assignment 58 on? 227 and 228. Yeah, let me just flip to that. On part B, number 1, part B, it says the distance you go in time d of t is approximately equal to the value of v at the sample point times dt. See, the wording gets a little confusing there. Write an equation for dy, the number of miles you go in dt hours. Well, you've got your strip here from your original graph, your points in the middle of it at t and then v of t or whatever you use there. So what it's really asking you for, they will call it dy on your quiz. This is the part that I said we hadn't really done one of yet, but it's on your quiz. So in other words, this, the dy, represents just a small portion of that area. So we have to write an expression that shows the area of this strip right here. So it's our v of t, which is 55 plus 12t to the 0.6. That's the height of it. What's the width of it? dt. That's all it's asking for there. He just gets a little wordy and carried away. Part C, write a Riemann sum for your approximate displacement y between A and B. Well, that's what we did on your notes page. So it doesn't tell us how many rectangles to use. It doesn't tell us whether it's left, midpoint, or right. So we write a general one with your summation sign. And we're going from A to B. So t equals A to B. And we're going to add up all those rectangles. So the rest of it is the same as what you had above. 55 plus 12t to the 0.6 dt. This is part C. So the basis, this piece right here, stays the same for the next problem. But we're writing a general equation. And then part D says write an expression for the exact displacement you get by adding up all the dy's and taking the limit as d of t approaches 0. So if I am now saying I'm going to take the limit of this expression in C, what does taking the limit change our sign to down here? The integral from A to B of 55 plus 12t to the 0.6 dt. And that is actually area equals that. So you're progressing from one thin strip to a bunch of them to finally an exact expression for the area there. Now part E, from there it just has you actually evaluate from 0 to 1. And then the second hour, so you're actually evaluating the integral we have there in part D. Okay, so you guys can finish that one up. Number 2, I want to talk about one term that they use that you probably have forgotten from geometry. Number 2, it says that you're supposed to sketch the graph of the parabolic region. Let me see if I have a page with this on it. Yeah. It talks about a circumscribed rectangle. That's the term I'm afraid you have forgotten. Okay. We've got, I don't have the equation written down here, but it's 6x minus, oh shoot, 6x minus x squared. So you have, we've got a parabola here, and it's going to hit again out here at 6. And at 3, 18 minus 9, so 3, somewhere right in here, you're going to have a graph. It's an upside down parabola like that. Now, the circumscribed rectangle means that it goes around this piece of the graph. So it's outside of it as opposed to inscribed, which means inside. So we're going to hit at the corners here, and then we'll hit the vertex, and that's what they're talking about when they talk about the circumscribed rectangle on problem number 2. Now, you guys have time to work, and it was 1 to 3 on your assignment sheet. I thought I had made it shorter. I'm sorry. But obviously, we need to do 4. Sorry. But I've gotten you started on 1 and 2, and you're only doing 4 problems, which you know why, because they're long. I know, they're long, but that's a change in assignment, so you guys have the rest of the time to work, and you've already gotten started on it.